This video is about the Maya44 XTE. As you can see from the manufacturer homepage, there are 7 different drivers available. The oldest one is from 2010 and the latest one is from 2015. And it's only the latest one that they say can work with Windows 10. And I'm now on a Windows 10 platform, so I will install this. Also note that the latest driver that can be used with XP, according to this, is version 1.07. I'm now running the 1.2.0 installer. Finish. Now I will start Linrad, and it's already set up. You can see how to do that on other videos. There is an IQ Plus connected to the sound card, so it's a 2-channel direct conversion radio for the 4 audio channels. And let's see what we have for audio here. That is A and A, and I have to use port audio. Y will be visible if I try to not do that, and you can see I have only 2-channel sound cards. So I escape and go again, U and A. And yes for port audio. And I think it's popular to use the ACU drivers with this card, so that would be 24 and 96 kilohertz and then 32 bits for best dynamic range, and 4 and 1. And then the SI570 3 here is what we need, and B, no, 0. And save this, X, X, and W. And I go for SSB mode, that is D. And here we are. I have a fairly strong signal at near the center frequency, and I click on it, and you can see it comes out as circularly polarized. That is fun because it's connected in parallel with both channels. Anyway, if I change the frequency, I go up a bit, like that. The polarization has changed a little bit. And here it has changed more. And here, even more. It looks like it's linear now. This means that the phase changes with frequency. In other words, there is a time shift between the 2 channels. That's not very good. And there are also glitches. I think they can be fixed, but that's another thing I will come back to later on. So I go a little bit further up in frequency, like that. And here the phase shift is now 0. And it looks like we have 45-degree polarization. But it's in the wrong way. It should be 45, not 135. Now what is more bothersome here is that when I exit, that's X, and then B, and then click again, this time I get a different polarization, because the time shift between the channels varies from time to time. X and B, I click again, and this time I get the second version of time shift, and then X and then B, and again, X, B, and again this one, X, B, and the other one. So if you run this sound card with map 65, you will have a problem that the phase between the two polarization is undefined, and that means probably a loss of up to 3 decibels. The glitches can be because I have not allowed any latency. Remember, I put 1. But there are other options here. So X, and I go for U and A, and use port audio for input. And there is which one is it? 4 channels? No, there is only one possible solution to get 4 channels. So this is what we could do. But there is one more thing, and that is, if I go here and U and A for sound card, and no port audio, and I say 1, and then, do you need more channels from the same sound card? Yes. And that is 2. And then use the extended format to allow more bits. 96 kilohertz. 24 bits. And 4 here. And 3. And B, and no, and 0. XX, save this. And then again, sideband. Oops, does not look so nice, does it? I move the frequency down until it comes within the passband here, and look at the polarization we have here. It has left circular, and the angle comes out at 43 degrees or something. And exit and back. This looks like the same. So this seems to be better. I have to repeat many times, of course, to be sure. But before doing that, I will do something else. Escape. And there is an icon down here somewhere. Recording devices. And this one, properties, advanced, and I want 2 channel 96 kilohertz, 24 bits. This one. Okay. And the other channel, properties, advanced. So. Okay. And close this. And now run Linrad. D. Looks much better, doesn't it? So I increase the frequency to come to a higher frequency where time shifts are more easy to see. And it says right 145, and I will go up and down X and B. No. This is now a different polarization. So using this other possibility did not solve any problem. X calibrate, and always in the correct order. That means A first. And I need more signal. Let's say minus 25. Something like this. And I want the calibration signal when it is close to the center to be about 1.5 kilohertz away from the center. Maybe. So I set the stepping to 3 kilohertz because 3 kilohertz is the default in this case. So when I step, you can see that the signal and its mirror are at the same separation from the center, here and here. So that's going to be good. So I step over the whole frequency range. And then compute a new calibration, that is U, and it looks like this. And there's not much to say about that, so press enter and then save this. Yes. And then I go back just to show that when I go down in frequency here, you can see that the mirror image is not very strong. What comes in now are the audio overtones. They are much stronger than the mirror. So this was successful. The next step is to calibrate the frequency response. For that I connect a pulse generator. Like this. And here you can see very clearly that the pulses that come, well, I stop it and stop it with G. It's very clear that the yellow and magenta track are at a different time as compared to the blue and red, and the time shift is very large. I can make X and B. This time the time shift is very different. It's significant but different. And this is completely useless for the noise blanker. X and U. This was with the two separate devices. So I go for AC. I am now running the ACO driver with latency 3. I had to start the Maya control window, and then it went okay. It didn't be sufficient to just exit Linrad and restart. That did not work. Something went wrong with the driver, and by starting this control window, where you can see I'm running the 1.2.0 32-bit version. Now it works. And I can make X. Sorry, I have to be active in the right window. X and B. And you can see that pulses come nearly at the same time. We cannot see the small differences here. X, B, X, B. It looks always more or less the same. So I go for the calibration of the frequency response. That's X, C, and B. And the repetition frequency is 113 Hertz. That could be suitable. Press enter. And Linrad is collecting now pulses and making averages. And there is a new feature, and that is the time difference between channels. It is 0.38 samples. And Linrad will take that into account, which means that the blanker will work properly if Linrad happens to be started with this separation between the channels. There is another alternative, so sometimes it will work, sometimes it will not work. Having collected 2,500 pulses has given enough statistics, so that is U, and I make the steepness less by pressing M. This is now a parabolic fall off rather than a Gaussian error function. It's a little bit less critical. So I press Y, and it looks flat and it looks good, all of it. So I say S to save, and then X and then D. Just escape and start again. I don't know why that happens, not very often. And here now I can try to enable the blanker, the smart blanker, and as you can see, it does not work at all. So X and B, X and B, X and B, I am hoping to get the same time shift back. So X and B, X and B, and it doesn't matter what I do. So I go for this C and remove the center discontinuity. I didn't do that, and that is sometimes necessary. So I say C, and I change the points near the center. It is 562 Hertz plus minus from the center that are excluded. I will exclude some more, let's say L, and I make it 2 kilohertz. And continue with this value, and then just A on each screen, and then save, and X, X, and D. Oops, now it works. So I make X and B, and now it doesn't work because it happened to come in the other time shift between the two channels. So I make X and Calibrate and B and enter. And here you can see time difference between channels. It's 0.99 samples. So it's different. So these are the two different values that happen to come up with the ACU driver using the 1.2.0 version of the Maya44 software. The 1.2.0 is now uninstalled, and I will try to install an older driver, which I have in this folder. It's the oldest. Close. Well, that's all. Maybe. We didn't get the control panel, so I open it this way. I have the installers. Maya44, and this is the 32-bit and the panel. What? Yeah, here we are. And now you can see this is the 1.0.0 32-bit panel. And if I go to the device manager and look at the properties, driver 1.0.0.0, so it is really the old driver now. And start Lindrad. And first look at the devices, that is U and A and A, and without port audio it is like before. So escape, and then I go to use port audio. Sorry, A, and yes. And here is now a microphone, channel 1 and 2, but it comes with 4 channels. So there is one new alternative here, and I select that. It is number 35. 96 kilohertz, of course, 32 bits, 4, and I give it latency 2, and the SI570, of course, that's for the IQ plus, and B, no, 0, enter, X, and save, and look at the screen. Now the calibration is still there for the other driver, so this is not correct. I redo the calibration. That's X, and C for calibrate, and B, because the balance between I and Q has not changed. And this is what I see with the old calibration still active. So I clear, you can see that it's 0.61 samples, that is the time difference. So I removed the old calibration by pressing A, and now you can see the delay is 0.98. Looks close to 1 sample, but not exact. And I wait for a while for this to stabilize, and then U and M and Y, and save this S and X, and again calibrate, and then I go for C, that's the center discontinuity, and I set the limit to 2000. The details of this center spur removal will be in some other video. Continue with current value, C, and then I press A for each screen, and S to update, and XX and D. And here we are, and the blanker works. And I make X and B, X and B, X and B, I have now stopped and restarted 42 times, and I stopped at the 42nd because I got the error here. Out of these 42, I have 5 cases of error and 37 that are in the correct calibration. By connecting the signal generator instead of the pulse generator, I can show what this means for the polarization readout. I have a signal at a high frequency here, and click on it, and you can see polarization fairly slowly adapts to something near 45 degrees. I speed it up by moving this line in the polarization graph. Now it's quicker. Well, it could be even a little bit more like this. And I click on the mirror image here just to show how polarization, how rapidly it changes now, the indicator. So I go here. You can see it says 45 degrees because the signals in the two channels are close to equal in amplitude. So I change the frequency and look at another frequency, and it's also 45 degrees. The reason why the image is a little bit stronger is that I had to adjust the cable lengths a little bit, because when I set it up I didn't think about doing this experiment, so I didn't choose equally long cables, and that changed the amplitude just a little. And it's convenient because I want to demonstrate that it's really measuring the polarization like this. So what we have here is the correct polarization indicator, and it's independent of the frequency. Now I will connect and exit and restart until I get in the situation where the error is present. After stopping and restarting several times, I now have Linrad running with the wrong time shift between the two channels. There is about 10% probability of getting into this case and 90% to getting into the one for which I have now calibrated Linrad. So I connect the signal generator and look at the phase of the signal that is here and close to the center, and I make the polarization adapt faster, and you can see this is the correct indication. But when I go up in frequency, let's say here, then it looks like circular. So it means the delta phase is wrong by 45 degrees, and that is probably a 3 dB loss if you are using MAP 65. And I continue upwards. Up here it looks linear again, but 90 degrees from the correct indication. So what you can do is have a test signal that is approximately equal in amplitude in both your antennas, but for which you know what is the proper polarization indication. So if you get it wrong like this, then just exit and then go back and look at the signal. Now it's correct. Now the blanker will work. As you can see, well, this is a very strong impulse noise source, so it doesn't look like it works so well, but actually it does, and that's not what I'm going for in this video, to show how to fine-tune the things about the blanker. That's another story.